Hey stats class, in the last video I showed you how to find a p-value if you're given a test statistic of a single-tailed test, hypothesis test. Well, now we're going to have a two-tailed test. And I'll show you the slight alteration you have to do here. Alright, so the same thing here. Again, this is a two-tailed test like I mentioned before. It starts off the same way as the last one. This is a two-tailed test because of the claim that not equal to. That's the alternate hypothesis. Anytime it's a not equal to, that's a two-tailed test. So we have a little bit in the left tail, a little bit in the right tail. Now when we do this, we're going to find our test statistic. Where does it fall on the number line relative to the middle, which is 0? So 0 is right there in the middle. 2.81 is going to be way over here in the right tail. And the p-value is the area. In the last video, it's just the area from that point on into the right tail. But because this is a two-tail test, I always refer to this as a ghost test statistic. It's not actually the test statistic, but it's the same one that would have lived in the left tail that's that same distance away. So 2.81 is 2.81 away to the right. What would be the equivalent 2.81 away to the left? Well, it would be negative 2.81 because 0 is right there in the middle. And so what we're going to do is find this area, the one on the bottom or the top, and then double it to say we could have been in that same position in the other tail because it's a two-tailed test. So because it's two-tailed, I have to consider being that far away in the upper tail or in the lower tail. So we basically find the p-value just like we did in the last problem and then double it. So because this is a test about a proportion, we're using z's. So that's the standard normal distribution. So that's second vars. We're going to go down to normal CDF. Right, our lower number is going to be where our test statistic is, the 2.81. Right, our upper number, again, right tail, we just keep on going into the right tail forever. So some big number with a bunch of 9s. Mean is 0, standard deviation 1 because it's a right tail test. Alright, if you don't have that setup option, you just make sure you put it in that order. Test statistic, 999s to go deep into the right tail. Mean is 0, standard deviation 1. So there's our number, but because it's a two-tail test, we just hit times. That's all we have to do, just times 2, and that gives us our p-value. So it's that same 2.002 in the right tail back down to the left tail. All right, round to 3 places, so we're going to round that 4 up to a 5 because that's a 9 there, the 0.005. All right, now that we've got that part done, we want to find what's our conclusion. So when the p-value is less than alpha, we reject. If it's greater than alpha, we fail to reject. So I've got a number in there. I can just hit second test and do that number. And answer, when you see answer, it's the previous value. Is that number, our p-value, less than alpha, which is 0.1? It's going to say 1 for true. So when it's true, that means we need to reject the null hypothesis. The p-value is less than alpha, so we reject. Again, if you understand that this number is smaller than alpha, you don't need to type it into your calculator. It's just if you struggle with decimals, comparing decimals. So this is less than this, so that means we reject the null hypothesis. When we reject, again, it's going to be B or D. When we reject, it's because there is sufficient evidence to support the alternate hypothesis. So that's going to be option B. So that's how we do a two-tailed p-value.